All right, we are on the last section of Chapter 20, Differential Calculus, and we are going to talk about higher order derivatives, which means that you take the derivative of a function, and then you take the derivative of the derivative, and then you take the derivative of that, and so on and so forth. Those are called higher order derivatives when you take the derivative over and over again. Well, first of all, why would we want to do that? The most common example that we talk about is measuring position at time x, so position being your y and time being your x. Well, if we're finding the derivative of position, then we're looking at how position changes over time. Well, we call that velocity. Velocity measures how your position changes over time. All right, that would be taking the first derivative. Well, would we ever want to know how that derivative, velocity, how that derivative changes over time? Would we ever want to know that? Of course we would. That's called acceleration. So acceleration is the derivative of the derivative of position. And so we call that the second derivative. All right, so it is important to take the derivative multiple times. All right. So this notation you're familiar with, f prime of x or dy dx, that's called, it used to be called the derivative, but now we'll call it the first derivative since we're only taking the derivative once. If I take the derivative again of that resulting function, that's going to be represented like this. F with two tick marks, which I will say f double prime, or d squared y over dx squared. And those exponents don't mean the same thing as you're used to. That's just a notation. And why the 2's go where they go, I have an explanation for that for those that really want to know. Why wouldn't the 2 go after the y and stuff like that? There is a reason for why those exponents go where they go. But that's just the notation for the second derivative. If I move on to the third derivative, then I might use 3 tick marks to do that. I would call that f triple prime, and then it would be d cubed y over dx cubed. And again, those cubes don't mean the same thing. It just means I'm taking the derivative 3 times. And so on and so forth. So if I get too far, then obviously these tick marks are going to get a little excessive. So what I do is I might represent the number of tick marks that would have been there by using a number in parentheses up here. So it would be the nth derivative of f of x, or I would use the other notation and I would say d to the n y dx to the n. And both of those mean I'm taking the derivative n times, however many times that is. All right, so let's do a couple of examples. We are looking for the second derivative. You can tell by the fact that there's 2 tick marks there. So f double prime of x, given that f of x is x cubed minus 3 over x. All right, well, first of all, let's clean this function up and make it look like something I can take the derivative of. So f of x, I'm just going to rewrite it, is x cubed minus 3 times x to the negative 1. All right, so I just rewrote it. I haven't taken the derivative yet, but now I can. So f prime of x, remembering my rules, will equal 3x squared plus 3x to the negative 2. Okay, so hopefully you see where that comes from. Then the second derivative means I'm going to take the derivative of what I just wrote down. And that will be the derivative of this, which is 6x, and then the derivative of this, which is minus 6x to the negative 3. And that's all you do. You take the derivative as many times as you're asked to in the question. All right, so let's do a second example where we're taking the third derivative of this function right here. And again, just based on the last term, it needs some cleaning up first. So f of x will equal x to the 7, that looks fine, plus x to the third, that looks fine, plus x to the 1, that looks fine. But let me change this last one to 2 times x to the negative 2. So again, I haven't taken the derivative, I'm just writing it more neatly so that I can apply my rules. So, first derivative, f prime is the derivative of x to the 7 is 7x to the 6 plus the derivative of x cubed is 3x squared plus the derivative of x is just 1. And then the derivative of negative 2x to the negative 2 is positive 4x to the negative 3. And that's the first derivative. Second derivative, I'm just going to take the derivative of what I just wrote down. So that will be 42x to the 5th plus 6x. And the derivative of 1 is nothing, so I'm not going to write that, minus 12x to the negative 4. That's the second derivative. And then one last time, I'm going to take the derivative of what I just wrote down. So f triple prime is 210x to the 4th plus the derivative of 6x is just 6, and then the derivative of negative 12x to the negative 4 is plus 48x to the negative 5. Alright, and there it is. That's the third derivative. I could go further, but I haven't been asked to. And notice that, this notation of the 3 in parentheses and the 3 tick marks means the same thing, but as I said, if you take the derivative enough times, you're not going to want to keep track of how many tick marks there are, so you'll probably want to use this notation. 3 wasn't very many, so I just stuck with 3 tick marks. Alright, so that is higher order derivatives. If you have any questions, please email me or send me a message on Facebook, and we'll do some practice on this tomorrow. I know you guys were probably surprised by the pop quiz that I gave you today, so get ready for more of those. There will be random pop quizzes, not regular pop quizzes, because it kind of takes the pop out of it. So maybe there will be a pop quiz on this, but maybe not. I don't know. But either way, we'll see you tomorrow.